Okay, let's finish up with our discussion of periodic trends by talking about ions. So, ionization energy, we said before, can tell us a lot about the number of valence electrons within an atom. But there is a specific rule that's basically going to govern everything that we do for the rest of the semester, and that's called the octet rule. And the octet rule states that atoms tend to gain, lose, or share electrons in order to acquire a full set of 8 valence electrons, meaning they want to fill up their valence shell. They want to fill up the s orbital and the p orbital in their outermost shell, which would add up to 8 electrons. So they're going to do whatever they have to do to get those 8. They're either going to gain, they're going to lose. If they do that, they become ions, or they're going to share. And in the next unit, Unit 5, we're going to look at sharing electrons. So the octet rule is very useful for predicting whether an atom is going to become a positively charged cation or a negatively charged anion, basically just looking at how many valence electrons it has and how many it wants. So let's take a look at an example. Let's look at the element chlorine. Now, when you look at the element chlorine, okay, if we were to write out chlorine's electron configuration, it would be 1s2, 2s2, 2p6, 3s2, 3p5, which means chlorine has 7 valence electrons. And if you look at where it is on the periodic table, if you count across from left to right, it has 7 valence electrons. It is in group 17. Now, chlorine wants 8 valence electrons. That's the octet rule. So how does it go from having 7 to wanting 8? It has to gain an electron. So when chlorine becomes an ion, it becomes an ion with a -1 charge, and its electron configuration now goes from 3s2, 3p5 to 3s2, 3p6, which is a full shell. Just like the noble gas that it's next to, it has a completely full shell. So things become ions to fill up their valence shell. They're either going to gain, and they usually gain 1, 2, or 3, or they will lose and go back to having a full outer shell. Now, you can tell which is going to happen based on where it is. So elements on the right side of the periodic table, meaning the nonmetals, generally gain electrons. Elements on the left side of the periodic table, meaning the metals, generally lose electrons. And we're going to spend a lot more time talking about ions when we get to the unit on ionic bonding. Okay, so the next thing we want to do is talk about our very last periodic trend, which is electronegativity. And I know that's a big word, but it's an important word. So electronegativity is basically its ability to attract electrons in a chemical bond. So electronegativity only applies to atoms that are bonded to other atoms. So the more electronegativity an atom has, the more it's going to pull electrons close to it, the more it will attract electrons. So here's our trend. Electronegativity decreases down a group and increases left to right across a period. So let's talk about why that happens. As you go across a period, what do we know about the radius of the atom? We know it's decreasing, right? And it's decreasing because we're adding more protons to the nucleus, so the electrons are more attracted. So the more protons a particular atom has, the more electronegativity it's going to have within a period because it's going to attract those electrons. Now, as you go down the periodic table, the electronegativity decreases because the bigger the atoms are, the more core electrons they have and the more shielding you get. And shielding is when electrons block the nuclear charge from the valence electrons. So think about there being a whole bunch of electrons in the way. So those valence electrons can't be attracted to the nucleus because they're being shielded by all the core electrons. So really big atoms that have a bunch of electrons won't have a lot of ion or electronegativity because their valence electrons are so far away and there's so much shielding going on within the atom itself. Okay, so that's why the trend does what it does. Now, if you take a look at the chart in your notes, you'll notice that ionization energy, electronegativity increases as you go across, but what do you notice about the noble gases? It doesn't have a value for electronegativity. Well, what do we know about noble gases? Do they bond with things? No, they don't. And electronegativity only applies to elements that are, or atoms that are bonded to other atoms. So the noble gases have no electronegativity. So when we talk about electronegativity increasing, it stops with the halogens. It does not include the noble gases. So the element with the highest electronegativity is going to be fluorine, not helium. Okay, so when we talk about electronegativity, make sure you leave out those noble gases because they don't bond, therefore they don't have any electronegativity. Okay, we are going to do a lot more practice with these trends in class. If you have questions, please come see me in tutorials and make sure you bring your periodic table.